I'm going to go to Fred, and I'm going to verify that Bob is still the primary. Yes, we verified that. Now, this is why I'm using a virtual machine. I'm going to go to Bob, and I am going to simulate a failure of the system. So I am going to go and stop this virtual machine, which basically simulates like somebody has completely taken the power out of the system, or the system has crashed, right? At the OS level, something really bad happened. So the system is dead. There's no clean shutdown. It's gone. Let's see what happens. So the application is currently paused. Okay, this time it's taking a little bit longer for the primary system, for the other system that is still alive, to negotiate and say, okay, I have a problem, but there it goes. It has now connected automatically to the other system. That's the only surviving system, and it has started to run. Okay. So in this particular case, we simulated not a clean shutdown of cache, but a case where you have an operating system level shutdown, you lose your power, or a big crash on the machine, and your other machine automatically, within seconds, takes over, and your applications just continue without stopping. This is our vision for high availability. And this is what you have available to you today in the versions of cache that you're running on, starting from 2010.2 onwards. Okay? This is what we call mirroring. Okay, so now back to the presentation. So now we can talk about the other stuff that we've seen. All the fun stuff, now we can talk about all of the rest of the stuff. So we have two goals for high availability, and two goals to make applications highly available. Number one, increase availability. Number two, decrease cost and complexity. Okay? And throughout the presentation, I will keep coming back to this goal because it's very important. Typically, customers configure failover clusters, and these are provided by operating system vendors. Microsoft has cluster services, Microsoft Failover Cluster. IBM has PowerHA, it used to be called HACMP. You know, many different versions of the same thing. Essentially, there are two systems. One of them runs in active mode. One of them is a passive server. This is an active-passive cluster. There's a heartbeat between the two, which is network-based. They also do some heartbeating based on a shared disk. All of your data sits on this shared cluster disk. Okay? Simple diagram, right? The purpose of this particular configuration is that if something bad happens to the active server, the passive server detects that there's something bad going on, and it takes over. Okay, so the green line is now moved to the active server. But what happens if the shared disk goes away? What happens if that crashes? The entire cluster that you've spent all this money on is useless because it's all running off of one shared component, which is the shared disk. And we see a few failures like this every year. Sometimes it's because of misconfiguration. Sometimes it's because of actual hardware failure. But something to keep in mind from a failover cluster standpoint. So, what does mirroring give you by way of high availability? It's best to describe it by drawing some pictures on the slide. So we had one system, cache system, Bob, right? We have another cache system, Fred. These are just independent systems that have their own disk, they have their own OS, they have cache running, and then there's this black box called the agent, which I'll talk about in a second. A combination of Bob and Fred, the two systems together, is the mirror. In the mirror, there's a role of primary for one system, and the other system becomes the backup. And these roles can change. As we saw in the demonstration that I did, the roles for primary kept switching between the two systems depending on which system I shut down. So one system has primary, one system has backup. Data always goes from the primary to the backup. The backup always sends acknowledgements to the primary. And there's this special agent thing that is essentially a very small service that runs outside of cache. And we use this agent when we try to do a failover. We use this agent to try to make sure that the system is up and running. We do it for some housekeeping work, basically. ECP, our Enterprise Cache Protocol clients, the demonstration had an app server in it. They essentially are what we call mirror aware. So they automatically connect to the running primary system. So if this system today is primary, all the app servers automatically connect to this primary. If a failover occurs, then they automatically reconnect to the other system. But the benefit of using ECP mirroring is that the failover essentially happens with just a slight pause. All open transactions remain open. Open locks remain open. All of your work is still available. You didn't lose any work while this failover occurred from one system to another system. And that's pretty fantastic. We introduced a concept which is kind of similar to cluster IP address in other clustering technologies. We call it the mirror virtual IP. The mirror virtual IP is something you can configure, and it gets assigned to the system that is running as the primary system. When a failover occurs, the new primary system acquires that virtual IP address. This is designed so that your web clients, your telnets, your SSH, your language bindings, your ODBC or SQL queries can come in through one IP address and always be directed to the system that is running as primary. For applications, if they use any of this, don't have to remember 2 IP addresses. Don't have to check. They just use this one virtual IP address and they're always in. Okay?